Hello. So we are back, and this time we have, that kind of job when the customer is sending only the boards. We have the faulty board, and we have a donor board. That's nice from the customer to send me a board for spares. Proper nice. So we have to fix this board. Probably he chose to fix this because it has dedicated graphic chip, and this one doesn't have graphic chip. It's integrated. Okay, so can we fix his board? We have nothing. I mean, we don't have like any buttons or I don't even know how we can test it. But let's try to find the fault and fix it. Now, I made so many videos about diagnosing a motherboard. What we checking first? Yeah, what we are checking first? First, we are checking the main power rail before we are plugging the charger. If the main power rail is not shorted, we are plugging the charger. After we plug the charger, we check in 3.3 volts LDO power supply, which is always on. Yeah, you don't have to press some button to have that power supply on. So getting the multimeter, I didn't check. I don't know nothing about this board. The package just arrived. I'm trying to get the jobs done in the same day, and eventually posted back on the same day or the next day. Depends how fast is the customer, paying the invoice. So the main power rail, we can check the main power rail on any capacitors, yeah? Any capacitor, not really any, but the input capacitor. Like you see, you have coil, MOSFET, and here you have a capacitor. I'm not sure if you can see. Yeah, one more time, coil. This is the output of the coil, you see. So we have the MOSFET, probably it's a dual MOSFET and capacitor. We have MOSFET. Here you have capacitor, but those capacitors are on the output of the coil. The input is, you see, this is a driver, and here is the input capacitor. So let's check here. I mean, this is the simplest one, yeah? So you see capacitor here. Check on the screen, 0.07 ohm. On the other one, 0.6 ohms, yeah? So the main power rail is shorted. So what is next? Next, let's grab the thermal camera and try to diagnose this board. Yeah, I mean, it's the easiest way. You can do it without thermal camera. Yes, you can. I done it, and I made so many videos. Like I was working like 10 years on that computer shop without a thermal camera, so I can't see a big problem. The only advantage with the thermal camera, you find the fault faster, and also you are using less current from the power supply, which can be considered like being safe, using less current. Okay, so I'll switch the power supply down to like 1 volt, a little bit of current. So let's see what do we have here. Here we have 0. You see the voltage get dropped to 0.1 volts. That means probably here is ground. I mean, even if I touch the ground, I will get same result on the power supply. So it means it's ground. Here is ground. Here is must be plus. Yeah, you see the voltage is a little bit higher. It's 0.02. That means here is plus. The resistance is very low, so I believe here is a shorted capacitor, not a shorted MOSFET, which is good. That means we can fix it. Let's raise the current, because the resistance is very, very low. Yeah? We have like 0.5 ohms. And with the thermal camera, let's have a look together. Something is hot there, but I don't think it's on this side of the board. Here somewhere. Huh. Okay, let's find. Let's find a shorted capacitor on this side of the board. Okay, let's come with the voltage here, yeah? So we can use the thermal camera here. Here is 0.03 and here 0.05, yeah? And don't tell me I touch exactly that capacitor. What is the chip? Is the chip or the capacitor? Is the capacitor. It's exactly that capacitor. You see? That's crazy. That's insane. Yeah, that's the capacitor. A nice and pleasant job. So what we are doing with the capacitors? On this channel, if you are new on this channel, we have a rule. We are desoldering the capacitor on this video, and we are soldering back the capacitor on another video. People. You know, I know it will make you happy, so I'll replace it. But you don't have to. And trust me, bad things can happen. If you try, I mean, if you put some stress on the board without any reason, like replacing a capacitor, I will choose, personally, I will choose not to replace the capacitor, just because I don't want to stress the board. I want to remove the capacitor and I have a working board. If I will be to solder the capacitor back, who knows? You know, this motherboard has like 5 layers. Bad things can happen, and I have a video which is not published yet because I'm still working on the job. The customer removed the capacitor, the laptop worked, and the customer tried to solder back the capacitor, and the board goes dead. But that will be on a next video. I'm waiting for the IO chip because the IO chip was shorted. I found it shorted. Okay, so we remove the capacitor. Let's use the donor board. We have the customer donor board. On the customer donor board, we don't even have that chip, you can see. So the place of the chip is here, and we don't have it. Okay, on that case, I will use a different capacitor from here, yeah? Great. Now let's solder the capacitor back. Perfect, yeah? Now, to check, to see if the main power is still shorted, let's check. So where do we check? Where we checked first time, and you can see it's no short, no short. Oh, sorry, I was touching something else. No short and no short. Yeah. So how we can test this? That's a good question. Let's plug a RAM memory. RAM memory. And wait. I don't even know what board is. I think it's HP, but I'm not sure. But can be Dell also. Anyone knows what board is? I believe it's HP. I think the customer said it's HP. I don't have his email. But anyway, let's plug the charger. HP charger, blue pin. Yeah, have it. No, sorry. It's not this one. This is Acer. Let me try and find it quickly. Oh yeah, it's here. Yeah. So let's check. Just pay attention on the power supply because this cable is connected to the power supply. Testing the board, yeah. So plug in the charger. We plug the charger and the board is taking like 30 milliamps, so it's kind of a good sign. Kind of. A little bit too high, but it's okay. Now, in order to test the board, we have to find the power button, you know. I can assume the board is working because it was a shorted capacitor. But I really want to test this. How we can find the power button? I have no idea. So the only way to find the power button is checking for 3.3 on those connectors. I know the board is not coming on. How unlucky I can be. I mean, usually when you reset the board, when you reset the BIOS, the board is coming on. But not this one. Nah. On this one, I have to spend another half an hour to find the power button. What's wrong with this board? 1 second. Let me see. Let me see what's wrong with this board. 1 second. Let's plug the charger. And this is fine. It's taking like 10 milliamps. I swear it's fine. Probably the board is good. Let's try and check the voltage on this connector, yeah? Wait, it's not on this side, right? Yeah, no, this one. Check on the screen. Check on the screen, 3.3. You can see it? So, like how I said, this board has a second fault. So we have 3.3 here. We have 2.2 here. Wait, what do you try to tell me? You try to tell me the 3.3 volts LDO power supply is not on? That's what you are trying to tell me? Huh? Okay, let's try to figure out why the LDO is missing, yeah? Let's see. So what the chip is doing exactly? Do we have any input voltage? No, we don't. Probably not. Okay, so the main power rail is present. That's a good question because if you remember, we swap a capacitor, right? And the main power rail is 0 volts. You can see on the screen 0. Okay, then where is the input circuit? And that's simple because the input circuit is here, yeah? So check here. Oh, someone replaced the MOSFET. Check there. Check there. Someone replaced the MOSFET. You can see? Okay. So what do we have here? Here on the input we have 18.9 and on the output we have 0. No, it is solder. Why do we have 0 on the output? Because the gate is 0. Why the gate is 0? Because my BQ chip is not healthy. On the BQ chip we have this double diode, right? That's the one, right? And we do have 18 volts. And that 18 should come on some pin. No idea which one. Yeah, here. So we have 17 volts on the BQ chip, yeah? But the BQ chip is not sending voltage to my MOSFETs. Now the question is why? Let me switch the... Can the BQ chip be dead? Can be, yeah. But let me try. 1 second, where are the MOSFETs? Here. Let me check both MOSFETs for short. So this one is good. And the second one is good, yeah? So both MOSFETs are good. Probably someone replaced this MOSFET, but they are good, are not shorted. And the gates are fine. Yeah, no shorted. So on this case, I suspect the BQ chip is dead. And I will replace that BQ chip quickly, yeah, from the other board, but quickly, yeah, because already we spent some time here. Good. And the other board, the BQ chip? Yeah, that's good. Now let's remove this one first. The chip position pin number 1 there, you can see it. Any more air? This is the power management chip. Okay, so we desolder the chip. Let's remove the chip from here. Good. Let's solder the chip back here. Yeah, he will be fine. He doesn't need flux. This is a nice chip. So it will be working or not, that's the question. Let me cool down the board. Yeah, it's fine, yeah. Let's plug the charger. And it's taking 10 milliamps. But it's going up to 130 and then goes down. I don't know, some weird thing. Let's check the voltage. Did you see the lights? Yeah, the power supply goes on limit. Yeah. Check there, the board started. You can see 600 milliamps. We have the lights here. So the BQ chip was dead. So the board is fixed. Now we have 3.3. It's not even point testing if we have 3.3. It's not even point. So the problem was the BQ chip. This one. This little prick. So we do have the RAM memory. Yeah, we have the RAM memory. The bus battery is not plugged in and the board is coming on by itself. So we can take the microscope HDMI out. But you can't see it. You can't see anymore. Plug the HDMI. We don't have HDMI. So I took a break because this board has display port and not HDMI. So I have to unplug the monitor, plug the monitor here and test it. But I made a picture. Yeah? So check here. Yeah, so I hold the heatsink over the CPU and GPU, cables plugged in, and we have picture on the monitor. It's a poster about the memory change, the memory size change. But that's not a problem, yeah? The board is working, yeah, it's working fine. What was the problem? A capacitor and the BQ chip. And I don't know the history of why someone work on that MOSFET, but it's working fine. Yeah. So I'll stop now. I will say thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.